Number one, this question considers two possible models for the occurrence of random events in a computer game. In a new computer game, each time a player performs an action, there is a random chance that the action will be boosted, meaning that it provides a benefit to the player. The designer of this computer game is considering two possible models for when to boost an action. In the first model, the probability that an action will be boosted is constant. Suppose the probability that an action will be boosted is 0.1. It means if no boosted, 1 minus 0.1, 0.9. Okay. Find the probability that the first boost occurs on the third action. Okay. A part one. I would like to start with probability x equal k. So we can model this situation using a geometric distribution. So I would like to using the geometric distribution. Uh, Probability x equal k is the probability that the first boosted occurs on the k action. After that, p is the probability of boosted. So I would like to start with the understanding on any given action. Okay. And after that, 1 minus p power k minus 1. 1 minus p, if p is the probability, it means probability of boosted, it means 1 minus p is the probability no boosted. Okay, is the probability of having k minus 1 no boosted. Okay, on the k action. Okay, so the probability that the first boosted occurs on the k action is given. We can writing by the formula probability x equal k equal 1 minus p power k minus 1 multiply p. This is the formula. The formula of the probability that the first boosted occurs on the k action. Better if I'm writing here. The probability that the first that the first boosted occurs uh, on on the K action. This is the formula. Okay. Now, given the probability 0.1 and K is 3. Okay. So if we substitute formula, into this formula, uh, okay, so we can determine the probability x equal 3 is equal 1 minus 0.1 power 3 minus 1 times 0.1. It is 0.9 squared times 0.1. And the result, I have calculated this, is 0.081, or in percentage, 8.1%. Next. A part 2. Find the probability that at least one burst occurs in the first 6 actions. Okay. All right. A part 2. Just now, we are going to calculate the probability if the probability equals 0.1 and the first burst that occurs on the third action, or K equals 3. If P equals 0.1, it means 1 minus P. This is if boosted occurs, and this one is if no boosted occurs. 1 minus 0.1 is 0.9. The probability of no boosted in 6 action, like this, we can determine probability, okay, no boosted in 6 action is 0.9 power 6. Okay, and the result is 0.53141. If A is number of boosted in first 6 action, so we can determine P is A greater than 1. Okay, it is 1 minus 1 probability no boosted. in 6 action. It means 1 minus this number, 0.531441. And the result, 0.468559. Or you may simplify or round it to 0.4686, or in percentage, that's 146.86%. Part B. Suppose the probability that an action will be boosted is P, where P greater than 0, less than 1. Explain why the probability that the first boost occurs on the X action is P multiply 1 minus P power X minus 1. Okay, part B. B1. There is, I will writing here several concept that there is no boost. There is no boost the first on the first X minus 1 action. Uh, it follow it's followed by y by one by one boost action. The second, uh, each action each action has a probability equals 1 minus p of no boosted. Okay. The third, the probability of no boosted the probability of no boosted on each of the first x minus 1 action is the combine of each one and each one is 1 minus p power x minus 1. Okay. So and the fourth on the x action on the x action, the probability x action is p. This is the probability of the x action. If we combine this theory, actually, we can write things like this, that according to this information that 1 minus p can writing as multiply 1 minus p 1 minus 1 minus p multiply until the x times of 1 minus p. So this multiplication, this multiply until x times, okay, and multiply by p. Okay, so we can writing that the probability equal 1 minus p as long as x times x minus 1 power x minus 1 times p. That is the probability, or we can state that the probability equal p times 1 minus p power x minus 1. Okay, so this is the statement. I would like to using this color to create the box. Okay, in box. Okay, next. B part 2. Let x be the number of actions until the first burst occurs. Hence, write down an expression using sigma notation for expectation x in terms of x and p. Okay, B part 2. This is the random variable x follows a geometric distribution, so the probability x equal x, it is the probability times 1 minus probability x minus 1 according to this theory. The expectation value EX of a geometric distribution is given by the formula EX equal sigma x equals 1 to infinite of x times p times 1 minus p power x minus 1. Or I would like to writing the formula becomes like this. Sigma x equal 1 to infinite of x times this probability in geometric distribution, like this. Next, C. By differentiating both sides of the above equation with respect to R, find an expression for sigma n a r power n minus 1 in terms of a and r. Okay. So we are going to find the left-hand side and right-hand side. Let's see. Left-hand side is a plus ar plus ar squared, ar cubed plus so on. This is the left-hand side at the left side. In sigma, we can writing like this. n equal 1 infinite of n times a r n minus 1. Okay. If n equal 1, when n equal 1, so it becomes 1 times a times r power 0. So a r power 0, it is a equal a. When n equal 2, it is 2ar power 1. So it is 2ar plus 2ar. When n equals 3, it becomes 3ar squared. Becomes plus 3ar squared. When n equals 4, becomes 4ar cubed plus 4ar cubed, so on. Now, actually, left-hand side, if you look the result, we can writing as sigma of a times r power n, because this is 0, 1, 2, 3, so on. Okay. And if we find the differentiation or differentiating of LHS, L is left hand side, it is sigma n ar power n minus 1. Okay. This is part 1. Left hand side. Next, right hand side, I mean. Right hand side is a over 1 minus r. That is right hand side. But according to this information, the differentiating that, it becomes the differentiation sigma n equal 1 infinite of a over this is according to this information that it becomes 1 minus r power 2. Okay. According to, because this is 1 minus r power minus 1. The differentiation, it means becomes minus 2, power minus 2, and this is power 2. Okay, so this one, the right hand side. What else? And show that the expectation x equals 1 over p. Expectation x equals 1 over p. It is part 2. The expectation x, this is x times a times 1 minus r power minus 2, okay, according to this information. And then when A equal P, R equal 1 minus P, and X equal N equal 1, it becomes 1 times A times P, I mean, this is P, okay, times 1 minus P power, sorry, 1 minus 1 minus P, 1 minus P power minus 2, and it is P times 1 minus 1 plus P. It is P times, this is 0, 1 over P squared. P over P squared, 1 over P is 1. EX. Next part D. Or this one. Okay. See already, next part D. It can be shown that variance X equal 1 minus P over P squared. Find expectation X and variance X when P equals 0.1. We're going to calculate the expectations and variance when P equal 0.1. P equals 0.1. So variance X 1 minus P over P squared. Okay. So it is 1 minus 0.1 over 0.1 squared. 0.9 over, this is 0.01. So 9 over 10 over 1 over 100. This is 90. Okay. Next, expectation X. According to the information that 1 over P. 1 over 0.1. 1 over 1 over 10 is 10. Part E. Okay, E, which one? In the designer's second model, the initial probability that an action is boosted is 0.2. And each time an action occurs that is not boosted, the probability that the next action is boosted increases by 0.2. Okay, so when occurs is not boosted, the next probability, the probability of the next actions is boosted increase by 0.2. Okay, underline this. After an action has been boosted, the probability resets to 0.2 for the next action. Show that the probability that the first boast occurs on the third action is 0.288. Okay. Uh, the probability, I would like to writing probability no boosted on the first action is 1 minus 0.2 equal 0.8. Okay. Because the probability of boosted on the first action is 0.2 according to the previous information. And on the second action, probability boosted on the second action, it is 0.2 plus 0.2 because it increases 0.4. So it means probability no boosted on second action is 1 minus 0.4 is 0.6. And next, the probability of boosted on third action, it means 0.2 plus 0.2 plus 0.2 or 0.4 plus 0.2. It is 0.6. So the probability is uh, the probability the first probability first boosted the probability on third action, the first boosted on third action is 0.8 plus 0.6 plus 0.8 times 0.6 times 0.6, 0.8, 0.6, 0.6. The result is 0.288, this one. That is part E. If let Y be the number of actions until the first boast occurs. Okay. Explain why Y less than or equal 5. Part F. Probability boosted or boast on the first action is 0.2. This is the initial probability of both. Okay, and the probability of the next action is boosted according to information increases by 0.2. and the probability of the next action being boosted reset to 0.2. So writing here for the note that the probability increases 0.2 and resets to 0.2. This is important notes. Okay. And at the first action, uh, the the probability both on the first action equals 0.2. Okay, 0.2. Yeah, 0.2. Right. According to this information. Next, at the second action, if the first action is not boosted, better if I am writing here, if the first action is not boosted, the probability, mm, yeah, better here, the probability boost on the second action equal 0.2 plus 0.2 according to this information increases 0.2, so 0.4. The third action, if if the first if the first two action if the first two actions are not boosted, it means the probability boost on the third action is 0.2 plus 0.2 plus 0.2 is 0.6 or 0.4 plus 0.2. At the fourth action, I need more space. Okay. At the fourth actions, if the first three action are not boosted, so the probability boost on the fourth action equals 0.6 plus 0.2, 0.6 plus 0.2. It is 0.8 or 0.2 plus 0.2 plus 0.2 plus 0.2. 4 times. Next, at the fifth action, if the four first four actions are not boosted, the probability boost on the fifth action is 0.8 plus 0.2. It is equal 1.0. This is important for us, this information. So after the fifth action, the probability of a boost is 1.0. It means the conclusion, con, conclusion, the conclusions, the uh, fifth action, wait, this conclusion actually, conclusion, okay, the fifth action definitely, definitely be boosted, okay, be boost, okay, the fifth actions definitely be boosted. Okay, next part G. The following table shows the probability distributions of Y. Find the value of M and the value of N. Okay. So according to our solution on this one, okay, part E. So M equal 0.8 times 0.4. G. M equal 0.8 times 0.4. It is 0.32. Okay. So supposed to be this is 0.32. So 0.32. How about this? N. So N we can calculate through N equal 1 minus 0.2 minus 0.32 minus 0.288 minus 0.0384. So, and I have calculated this n equal 0.1536 on my calculator like this. So the solution here I have to written here, okay, n 0.1536. Next. The next question, part 2. Show that expectation y equals 2.5104 Okay. To calculate expectation y, it means 1 times 0.2 and plus 2 times 0.32 plus 3 times 0.288 plus 4 times 0.1536 plus 5 times 0.0384. To expectation y, 1 times 0.2 plus 2 times 0.32 plus 3 times 0.288 and so on. And the result is 2.5104. This is 4 times afterwards 5 times. And the result is this one. Next, part 3. Find variance y. Okay. So variance y is sigma part 3 variance y sigma y squared times probability y equals y, or it is 1 squared times 0.2 plus 2 squared times 0.32 plus 3 squared times 0.288 plus so on. You may continue to writing that. And I have calculated the result 1.18749 or rounded to 1.187 or 1.19, three significant figures. Next question. Use the expression given in C part 2 to find the value of P for which expectation X equal expectation Y. According to uh, part, part C2 that the X equal 1 over P. C part 2. H. According to C part 2 that expectation X is 1 over P. And then expectation Y, it is 2.5104. So expectation X, X equals EY, or 1 over P equal 2.5104. So P equal 1 over 2.5104. And the result is 0.398342. rounded to 0.398. That's basically figures. Next, this is part 1. Here's part 2. Find variant x for this value of p. Variant x on C part 2, okay, variant x, this is p, and the variant x equal 1 minus p over p squared. This is according to part C2. So it becomes 1 minus this number, 0.39842 over 0.39842 squared. And if you calculate this, the result is 3.791730, or rounded to 3.79. Three significant figures. So if you compare with variant X and variant Y, variant X is greater than variant Y. Part 3. Hence, determine with a reason which model provides a more consistent experience for the player with respect to the boosted action. More consistent experience for the player, okay? This is about the game designer, okay? So it's part 3, sorry, part 3. Since variant X greater than variant Y, the second model, okay, the second model of design, so the second model of design is more consistent. It is more consistent experience. It's more consistent experience. That is the conclusion. Number 2, this question investigates a ratio of length found from the line passing through the points of inflection of a quadratic curve of the form y equals x power 4 minus mx cubed plus nx. The curve y equals x power 4 minus 3x cubed plus 3x has points of inflection at B and C. B and C are inflection point, this point and this point. The line passing through B and C intersects the curve again at points A and D. This is shown in the following graph. Find the second derivative, right? The second derivative. So if the function y equal x power 4 minus 3x cubed plus 3x. So the first derivative, 4x cubed minus 9x squared plus 3. And the second derivative is 3 times 4 is 12x squared minus 18. Okay, minus 18x. This is the second derivative. B. Find the coordinates of B and C. If you look this graph, that coordinate point B is 0, 0, origin point. Now we're going to find C. Coordinate point B is origin 0, 0. Now, how we determine coordinate point C? C is on inflection point. If you look this, actually C located on inflection point. So inflection point, uh, actually, the distance from the maximum is half of the distance of the maximum point and minimum point. So inflection point at the middle of maximum point and minimum point. Okay, but now uh, we're going to determine C through the rule that at the second derivative inflection point inflection point occurs occurs uh, when the second derivative equal 0. Okay, so it means 12x squared minus 18x equals 0. So factorize x times 12x minus 18 equals 0. X equals 0, or 12x minus 18 equals 0. So x equals 18 over 12. 3 halves. And then after that, substitute x equal 3 half into y equal x power 4, the function minus 3x cubed plus 3x. Right? If you substitute into this equation into x, 3 half will be 3 half power 4 minus 3 times 3 half cube plus 3 times 3 half. It is 81 over 16 minus this is 162 over 16, 9, 72, 9 times 8. And if you calculate, the result is minus 9 over 16. So the coordinate point C is 3/2 and minus 9 over 16. Next, question C. Show that the equations of the line through B and C is y equals minus 0.375x. Part C. We're going to determine gradient first. Gradient gradient through D, yeah, through D or with coordinate point, not D, C, I mean. Gradient through coordinate point C, through coordinate point C, 3/2 minus 9 over 16. The gradient through this coordinate point is m equal minus 9 over 16 over 3/2. So it means minus 9 over 16, 2 over 3. So m equal, divide this 3 and divide this 8. So minus 3 over 8. This is the gradient. Now equation. Equation passes through passes through C and gradient. We can determine through this rule that y minus y1 m x1 minus x minus x1. Okay. The next is substitute. This is x. This is x1, y1. This is m. Y minus 9 over 16, 3/2, x minus minus 3 over 8 here because gradient m, 3/2. So y plus 9 over 16 minus 3 over 8 x plus 9 over 16. Y equal minus 3 over 8 x, 9 over 16, minus 9 over 16. Will be y equal minus 3 over 8 x. Or y equal minus 0 point, wait, based on this question, let's see, minus 0.375. X. So 3 over 8 is minus 0.375x. This one. Next, part D. Find correct to 3 decimal places the x coordinate of D. If you look this graph, D here, actually we can gain the x coordinate D to part D, x coordinate of D. Right. Through this rule that y equal y, it means x power 4 minus 3x cubed plus 3x equal minus 0.375x. I have sketched on my calculator and gain the coordinate point, and this the graph like this. It x, the graph like this. Okay, and the straight line, the straight line passing through C and D. This is B, B inflection point, and also C inflection point, and it is D. And on my calculator, uh, coordinate, x coordinate, the coordinate point is 2.42705, comma, minus 0.91014. This. So x coordinate of D, the x coordinate of D is 2.42705 rounded to 2.427, 3 decimal places. Next, part E. Question E. Now consider the general curve y equal x power 4 minus mx power 3 plus nx, where n and n element of real number and m greater than 0. Find the x coordinate of the 2 points of inflections in terms of m. Okay. Part E. The function is y equal x power 4 minus mx cubed plus nx. And the first derivative is 4x cubed minus 3nx squared plus n. And the second derivative, 12x squared minus 6mx. The occurs when inflection point occurs when the second derivative equals 0. The inflection point occurs when the second derivative equals 0. So it means 12x squared minus 6mx equals 0. I'm going to factorize it, becomes x, 6m, or 12x minus 6m equals 0. So 12x plus 6m, then x equal 6m over 12, or half m. So this is the x coordinates of the 2 points of inflection in terms of m. Half of m, or m half, like this, same this one. F. Let these points of inflection be B and C. Okay. The line passing through B and C intersects the curve again at points A and D. Okay. Let XA be the x coordinates of point A, and similarly for XB, XC, and XD. It is given that XA, XB greater than XA, XC greater than XB, XD greater than XC. Write down the coordinates of B. Coordinates of B. F point 1. F part 1. Point B, of course, is 0, 0, because point B, the point B located on the origin, or 0, 0. Part 2. The question is, find in terms of M and N the coordinates of C. Coordinate point C, but in terms of M and N. The function is y equal x power 4 minus mx cubed plus nx, which is x equal m half, or half m. Same. So substitute x equal m half into this equation. Becomes m half power 4 minus m times m half cubed plus n times m half. It is m power 4 over 16, m power 4 over 8, then plus mn over 2, or becomes this is m power 4 over 16. We have to set becomes the same denominator times 2 to m power 4 plus 16 plus mn over 2 becomes 1 over 16 m over 4 plus half mn. I would like to factorize it becomes m half m times n minus 1 over 8 m cubed. Yeah, so like this. So this is why. So it means the coordinate point C is this one x m half, and this one half m times n minus 1 over 8 m cubed. This is x and this is y. Next, G. Show that the equation of line through B and C is this one. So line through origin and then C, the coordinate point C, we gain already, and we are going to prove that the equation, the straight line is this one. Okay. The line equation, the line equation uh, passing through B, so origin 0, 0, and C with coordinate point this one, m half and half m, n minus 1 over 8 m cubed. Okay, we are going to find the line. Uh, we need to find gradient. The gradient or m is y over x, half m, n minus 1 over 8 m cubed over m half. So half m, n minus 1 over 8 m cubed times 2 over m equal 1 equal 1. So it is n minus 1 over 8 m cubed. This is the gradient. The gradient and the straight line through this point, through C, with gradient this one. Next, I'm going to to find the straight line through this rule that y minus 1 equal m x minus x1. This is x1, y1, it is x1, and y1 is 1, and m this one. So uh, y minus, or better if through this one, sorry, through 0 and 0. Through b and gradient m n minus 1 over 8 m cubed. Okay. 0 is simpler than through this one. N minus 1 over 8 m cubed x minus 0. Y equal n minus 1 over 8 m cubed x. So this is the equation. The equation passing through B with gradient n minus 1 over 8 m m power 3 or m cubed. Next question. H. Show that xa is x coordinate of point A. Xa equal m over 4 minus m over 4 square root 5. Okay. H. There are two functions, y equal x power 4 minus mx cubed plus nx. And the second is straight line n minus 1 over 8 m cubed x, or we can expand nx minus 1 over 8 m cubed x. If y equal y, because we are going to determine x, it means this function same with this function. So x power 4 minus mx cubed plus nx equal nx minus 1 over 8 m cubed x, and x equals 0. Next becomes x power 4 minus mx cubed minus, plus, 1 over 8 m cubed x equals 0. And I would like to factorize x, becomes x cubed minus mx squared 1 over 8 m cubed equals 0. If divided by 0, this equation becomes cubic equation, x cubed minus mx squared plus 1 over m cubed equals 0. All right. We just have information that x coordinate point A, x coordinate point B, x coordinate point C, and x coordinate point D. X coordinate of point A, point and point D, we have no information. Just x coordinate of point B, x coordinate of point B is 0. while x coordinate point of point C is m half. Okay, so we are not going to involve point B, just point A, B, point A, D, and C. In cubic equation, same with quadratic equations, we can there are two rules about x1, x2, and x3. So I would like to apply that rule into this problem. The rule says like this: x1 or xa plus xd plus xc equal coefficient of x squared minus of coefficients x squared minus of minus m, or xa plus xd plus m half, because x coordinate of c is m half, equal m. Now I would like to create this equation becomes xd. xd is m minus m half minus xa. So xd equal half m minus xa. I prefer xd. You may create your own equations. If if you like xa, it's okay, no problem. If xa, it means xa equal m half minus xd here. The other rule says that x1 times x2 times x3 equal minus coefficients of this one. So xa times xd times xc equal minus of this one, coefficients of x power 0, m cubed over 8. So xa equal, I would like to substitute this xd, m half minus xa, and xc is this one, m half minus m cubed over 8. Now multiply this, becomes m xa over 2, xa squared, m half equal minus m cubed over 8. Next, multiply. I'm going to move here. Multiply this, becomes m squared xa over 4 minus mxa squared over 2 becomes, it becomes plus m cubed over 8 equals 0. Now multiply all terms, multiply by 2 over m. If multiply by 2 over m, it becomes, this is m over 2. xa, this is minus, becomes 1, xa squared times plus, this is m cubed, oh sorry, m squared over 4 equals 0. And then times minus 1. If times minus 1, times minus 1 becomes xa squared minus m half xa minus also m squared over 4 equals 0. This is quadratic equation, which A equal 1, B equal minus m half, and C equal minus m squared over 4. I would like to find discriminant. Sorry. Discriminant is b squared minus 4ac. So minus m half squared minus 4 times 1 times minus m squared over 4. M squared over 4, and this becomes plus 4m squared over 4, or the root 5m squared over 4. Okay, and it becomes square root 5 half m, or m half square root 5. x1, xa, we can determine through minus b over minus b. Minus of this one, minus m half. Plus minus. Plus minus square root z, it means plus minus is 1. M half square root 5 over 2 times a, 2 times 1. But according to the equation that we have to prove that, okay, here, question, that xa is m over 4 minus, not plus, minus m over 4 square root 5. So, therefore, I will not using plus, only minus here. Okay, and minus. Okay, so it becomes m half minus m half square root 5 over 2, or m half minus m half square root 5 times 1 over 2. Okay, so it's going to be, it becomes, this is m over 4, and then minus m over 4 square root 5. Yeah. This is x a. Let me we look question. Sorry, this one, same. So xa equal m over 4 minus m over 4 square root 5. Now, I hence find the exact value of xb minus xa over xc minus xb. I xb minus xa over xc minus xb. We have information that xb or x coordinate of point B is 0, xa or x coordinate of point A is m over 4 minus m over 4 square root 5, and xt is m half. So now substitute this information into this uh, this problem, this fraction. So 0 minus m over 4 minus m over 4 square root 5 over m half minus 0. So it becomes minus m over 4 plus m over 4 square root 5 over m half, or minus m over 4 plus m over 4 square root 5 times 2 over m. I need more space. Becomes, the multiply becomes minus half and then plus half square root 5. Okay. Or half square root 5 minus half. Or we can write it like this. Square root 5 minus 1 over 2. This is the solution.